Now, the circle at the right represents Earth. The radius of Earth is about 6,400 kilometers. Find the distance d to the horizon that a person can see a clear day from each of the following heights h above Earth. Round your answer to the nearest tenth of kilometer. Let's solve now number 11 here. In number 11 here, this is a circle, and this is that is tangent to the circle here. This is a circle. This is the radius of a circle. This is another radius. And here we have 2,500 because h here is 2,500. And I need to find d now. So how can I find the distance d to the horizon here? So here, imagine now there's something here that is above. There's a man here as an example. I want to find d now. Look at the triangle A or EBC. EBC. Is it a right triangle? Is it right?
Yes.
So since this is a right triangle, and here is 6,400, BC, it is unknown, and now notice the length of BE.
BE is 2,500 plus 6,400.
Yeah, so you have to add 2,500 plus 6,400. So which is 8,900. Now what I need to find BC. Since B, I wrote it wrongly, is it right? So here it is 8,900. Here it is 6,400. I need to find D. Where's now the hypotenuse?
8,900.
Yeah, it is 8,900 squared. So I will go to the Pythagorean theorem equals 6,400 squared plus D squared. Then 8,900 squared minus 6,400 squared, you will get this big number under the square root. You will find that D will be 6,184 kilometers. Yes, 6,184.65. Do you have any question?
No, thank you.
Okay.
Teacher, what do you mean about question 9 is 5 kilometers and question 10 is 1 kilometer?
Here, that means here, here we say it is 6,400 meters, and here it is 5 kilometers. The distance from the earth up to the tower, as an example. So when you want to find the hypotenuse, the length of the hypotenuse, you have to say 6,400 plus 5.
Okay, thank you, teacher.
You are welcome. But if you have, say, 2,500, you have to add 2,000. Oh, here it is meter.
Yeah, like that I asked you.
I solve it as kilometer. Okay.
Yeah.
So here it is 0.2500 over 1000, which is 2.5. So here we have 2.5. So we have now 6,400, 2.5. You get this answer, the square root of the answer. So it will be 178.9 kilometer. This will be the final answer, yes. Now let's talk about theorem 12.2, which is a converse of the theorem 12.1. In this theorem here, if a line in the plane of a circle is, if there's a line that is passing out of the circle, touch it as one point, and this line is perpendicular to a radius, so I will say that this line is a tangent line. This is a converse of a theorem. Okay, if an ray AB perpendicular to the line segment of OP at a point P, so that's mean a ray AB is tangent to a circle. Okay, the first one, theorem 12.1, we said that if the tangent line is perpendicular, there's a line, tangent line that is perpendicular to a radius, so the angle will be 90 degrees. Here, if there's a line that is that is intersect with a circle at point P and perpendicular with a radius, this line is a tangent line. So let's now use this theorem here to solve this type of questions. In this one here, we have a circle. They told me now that the length of AB is 12, and of this one here from out of the circle up to A is 8, and they asked me now to find the radius of a circle. They asked me to find the radius of the circle. Now look at this triangle here.
Teacher?
Yes.
Teacher, can I use here the trigonometry theorem?
Why?
Because I want to find x, so I have 90 and I have a side. So like this, I can use the cosine.
No, see, miss, the trigonometric ratios only to find if you have angle with side, you can use the trigonometric ratios. If you have two angles, you need to find the other angle, you have the third angle, you have to use the trigonometric ratios. But if you deal with length only, you must use the Pythagorean theorem. So here there's no angles.
Oh, okay.
How can I use the trigonometric ratio?
Yes, right.
I need just only the Pythagorean. So let's find x here now. I now need to find the radius. Now look at the yellow triangle. What is the hypotenuse here?
It's 8 plus x.
8 plus x. So 8 plus x squared, which is the hypotenuse. Did you remember the Pythagorean theorem? A squared plus b squared equals c squared.
Hypotenuse.
So the hypotenuse squared equal the leg, the first leg plus the second leg. What is the length of the first leg?
12 squared.
12 and x.
X squared. And the second one, 12 squared.
12
Bravo.
squared.
Now, when I have 8 plus x squared, how did you solve it here?
By using the square roots, first of all.
By saying x squared plus 16x plus 64.
Bravo. Here, now, Rose, if you say the square root, you cannot because they are added. X squared plus 12 squared, you cannot cancel the square root. You cannot make like this. This is false. If they are multiplied, you can cancel them. But if they are added, you cannot. So what you have to do here, you have to find 8 plus x squared. Now, all of us know that if you have a plus b squared, what you have to say, it is a squared plus 2ab
multiplied.
2a
plus b squared.
plus b squared.
And if you have a minus b squared, what did you have to say?
A squared minus
minus 2ab
plus b squared.
plus b squared. Bravo. So let's continue here. So 8 plus x squared is 8 squared plus 2 times the first one times the second one plus the second one squared. So I have 64 plus 16x plus x squared. Let's now write it here up. So x squared plus 16x plus 64 equals x squared plus 144. Then so what did we have? We have 16x minus 4 minus 4, 0. 16 minus 4 is 8 equals 0. Then I need to find x. How?
Take 80 to the other side and divide by 16.
Yeah, so let's say that plus 80 plus 80. So say that 16x is 80. Then divide by 16. Divide by 16. So x is divide by 8 is 2. Divide by 8 is 10. So it is 5. So the radius of the circle here is 5. Is it clear?
Yes.
What is the length of the hypotenuse?
13.
13.
Teacher.
Yes,
This is a 13, 12, 5 triangle, so the angles should be 90, 22 point something, and 67.38, right?
13, 12, maybe.
Because I calculated it once, I memorize it. If it's 12, 13, and 5, the angles will be as such.
Let's see here. Let me see. So I don't know. I don't memorize them. So let's say 12 over 5. Yes, C is 67.3 and A it will be 22.6. Exactly.
Thank you.
You're welcome. Now, so by now, do you have any question?
No.
Let's solve this one here. We have the same idea and got it 3. Here we have a radius, we have 10, we have 6. I want to find the radius. Yeah. What is the length of the hypotenuse here? As I told you, I need, since I'm dealing with dimensions only, so I must use the Pythagorean theorem. So why? Okay, this is what is the relation with it with our theorems? This helped me that this triangle this helped me that this triangle is right triangle. That's helped me to find any unknown dimensions. So since that a tangent line is perpendicular to a radius, so it makes a right triangle. To solve a right triangle, two things: Pythagorean theorem or trigonometric ratios. If it is not a right triangle, I cannot use the Pythagorean and the trigonometric. Both of them are used only in the right triangle. Miss, excuse me 1 minute, please. So I want to see who is knock on the door. Yeah. So here. So if I'm talking about right triangle, so I can use the Pythagorean or trigonometric. If it is not a right triangle, I cannot use either of them. So let's come back here. So we have a right triangle. Here we have 10. Here we have 6 and x. And here we have x. And I need to find the radius, x. So what is the length of the hypotenuse here?
6 plus
X.
x.
The hypotenuse is 6 plus
6 plus x to the
Equals x squared, the first leg, plus the second leg.
squared.
Then here, let's write it as x squared plus 12x plus 36 is done. X squared plus 100. So 12x minus 36 minus 100, which is 64, equals 0. Then I need to find x. Let's take 4 as a common factor. What did you have here? We have 12x and 64. Let's now factorize them. 12x is 4 times 3 times x. 64 is 4 times 4 times 4. 4 times 4 is 16 times 4, 64. Yes. So if we take here 4 as a common factor, what did we have left here? We have 3x minus 16 equals 0. Then, if we have now, as you took before in grade 8, if you have a times b equals 0. So what does it mean?
Either a or b is equal to 0,
bravo.
but 0
So
cannot
A,
equal 4.
It could be 0, and b, it could be 0. So let's come back here now. So what does it mean? That's mean if I have here in this equation, which is 4 times 3x minus 16 equals 0. So that's mean 4, it could be 0, or 3x minus 16, it could be 0. Either A or B. Now, can I say that 4 equals 0?
No.
It cannot happen. So I will go now to 3x minus 16. When you solve it, you will find that x is 16 over 3. This will be now the radius of a circle with a center O.
Wait, teacher, can you repeat the 4? Like, what did you do here?
The 4? What do you mean?
Like, what do you mean about 4? Yeah, 4, it can't be equal to 0, but what did you do after?
Here?
Yeah, and the 4 equals 0. You make
Here, I told you, there's A times B equals 0. So what does it mean? It could be A, it could be 0, or B, it could be 0. So this is A, it could be 0, and this is B, it could be 0.
Yeah,
4.
can we just skip 4?
Eh?
Can we just skip 4?
Yes, you can. Yeah, but here just to explain, to remind you, yeah.
Thank you, teacher.
We can take it as 3x minus 16. And or we can solve it without this one, but just here I want to remind you. You can say that it is 12x equals 64, then x is 64 over 12. When you simplify it, you will find that it is 16 over 3. You can do this one also. Fine. Let's see here now. Now, in this problem here, they told me that sometimes there's an lines that is passing or that is intersect a circle, but this line, it couldn't be a tangent line, because the tangent line, it must be perpendicular to the radius. So when can I say that this is a tangent or this is not a tangent line?
If it forms a right angle or not.
Yeah, exactly.
With the radius.
If we have, I told you that if the tangent line is perpendicular to the radius, so it makes or it forms a right triangle. But if it is not a tangent, it didn't form a right triangle. So let's come back. So like, I want to draw it here. So if we have a tangent line that is perpendicular on a circle or a radius, I mean, so it's make a right triangle. But if the tangent line does not perpendicular on the radius, so it doesn't make a right triangle. So how can I see now if we said before, sorry, that if there's one tangent line is perpendicular, so we have a right triangle. Since we have a right triangle, I can use all the properties of the right triangle to solve what did I need for the circle. You help me, I will help you. You help me that the tangent line is perpendicular to a radius, so it forms a right triangle. So I help you with an Pythagorean theorem, with an summation of the angles to find any unknown things you need. But if it is not perpendicular, you will not give me a right triangle, so I cannot help you. So how can I know that if this is perpendicular or no? How can I know? By check if we have a right triangle or no. If we have a right triangle, I will say it is perpendicular. If it is not, I will say that it is not perpendicular. So let's make here the tree. So if I have, or if I form a right triangle, if we have a right triangle, so the tangent line perpendicular to the radius. If it is not, so the tangent line is not perpendicular to the radius. Then, a second step. How can I know now? I mean that if any given dimensions, any 3 dimension, it makes a right triangle. Look at this one here. If we have 3, 4, and 7, is this a right triangle? No. I told you it must be 3, 4, 5. No. Why? Because 3 squared plus 4 squared, it didn't equal 7 squared. So this is not a right triangle. So since it is not a right triangle, so I will not say this is perpendicular to each other. But if I have triangle like this, and 3 squared plus 4 squared equal 5 squared, this is true. So that's mean it is perpendicular. Since it is perpendicular, so that's mean a line that is, sorry, I don't know how I can do it now here. That's mean there's a line that is perpendicular to a circle, which is a tangent line. So I can say that the white line segment is perpendicular to the radius. Is it clear?
Yes.
Yeah.
Fine. Now let's come back here. So in this one here, I want to see now if ML is a tangent to a circle or no. I told you if I say I want to say this is a tangent, so it must make a right triangle. So how can I know now if this triangle is right or no? By checking using the Pythagorean theorem. Let's see now. If where's the hello, we said all of us know that if this is, sorry, I want to change the color here. If this is a tangent line, if this is, I have to assume that this is like a hypotenuse. If this is an tangent line, so this will be a right triangle, a right angle. So where's the hypotenuse of the triangle? It will be 25. So this is the hypotenuse. So I want to see now if the hypotenuse, which is 25 squared, is it 24 squared plus 7 squared? So I want to check if 25 squared, is it equal 24 squared plus 7 squared? I want to see. Now, 24 squared, if you find it, it is 576 plus 49. If you add them, what did you get? 625. Is the square root of 625, is it 25?
Yes.
Yes. So that's mean, since this is a right triangle, so since it is okay, so this is a right triangle. These dimensions is the dimensions for the right triangle. So since they are right triangle, so that's mean we have a right angle. Where's this is right angle? This is here. So this is since we have a right angle, so that's mean NL is perpendicular to the line, which is line ML. So I will say that ML is a tangent line because ML is perpendicular on the radius. Since it is perpendicular, so it will be a tangent line by using the converse of the theorem 12.1. 12.1, yes. Is it clear?
Yes, teacher.
Yeah.
Yes, teacher.
Let's solve now this one here. If NL equal 4, NL is 4, and NM is 8. So is ML is tangent to a circle? So
No,
where's the angle? It is here. This here is the right angle. So where's the hypotenuse? It is 8. Why? Because we know that the side that is opposite to the right angle is the hypotenuse. So 8 squared is 4 squared plus x squared. I think you have to keep. It's 7.
It's 7. It's found.
Yeah, I was like, well, then we can find it to be a tangent. That's the case.
So NL is 4 and ML is 7 and NM is 8. Okay, sorry. So this is the right angle. So now we have to see that if 8 squared, is it equals to 4 squared plus 7 squared? Let's see. 64. 16 plus 49. Now add them. 9 plus 6, 15. 4 plus 1, 5 plus 1, 6. Is 64 equals 65?
No.
No. So that means it's not. So this is not a right triangle. So since this is not a right triangle, so there's no perpendicular angle. So ML is not perpendicular to the radius. So ML is not a tangent line.
So teacher,
Yes.
so if the line is tangent, it should be right triangle, right? If it's not, so it's not a tangent.
Yeah, exactly.
Okay. Thank you, teacher.
Yeah. Now, in this one here, we have the same. Let's choose number 15 as an example. We have to see that if whether a tangent is shown, if this is 50 and this side, I mean, if it is tangent or no. There's a right triangle here. So this will be the hypotenuse because it is the opposite to the right triangle. So is 16 squared equals 15 squared plus 5 squared? Let's see. No. 15 squared, which is 25 plus 25. Is it 16 squared? Let's add them here, which is 250. Is it equal to 256?
No.
No. So I will say that this is not a right triangle. So this tangent line is not perpendicular to a circle.
Teacher, concerning about our quiz, about the worksheet, do we have time till Wednesday to solve it? Or we should...
Yeah, I'm waiting you. Number 16.
Teacher?
Yes.
Yes. I got it as yes.
I got it as a right triangle, which is 42.25 equals 42.25.
So yeah, 6.5 squared. Let's see if it is 2.5 squared plus 6 squared. You check them. And 6.5 squared, which is 42.25. If you add them, you will get the same answer. So that's mean this is a right triangle So there's a tangent line. I don't know its name. So this is a tangent line is perpendicular to a radius.
And teacher, the tangent is 6 pi.